Using an area model to add fractions. The area model is also called a rectangular grid. So using an area model or a rectangular grid to add fractions. All right, so we have the add-ins 2/3 and 3/4. The first thing we need to do is estimate so we know how large or small our sum's going to be. 2/3 is about 1/2, and 3/4 is about 1. So 1/2 plus 1 is 1.5. So my sum should be about 1.5. We're going to use the denominators to create a rectangular grid or an area model. So I have the denominators 3 and 4. So I'm going to create a 3 by 4. 1, 2, 3 by 4. 1, 2, 3, 4. And I'm modeling 2/3, so I need to find 3 of something. That would be 1, 2, 3, 4. That's too many. Let's try going up and down. 1, 2, 3. There we go. And then I partition the shape into thirds, and I need to model or shade in 2 of the 3. So here's 1/3, 2/3. All right, now to use the rectangular model to find the equivalent fraction. 1, 2, 3, 4. 4/8, 4/8, 12. So 2/3 is equivalent to 8/12. Now let's use a 3 by 4 rectangular grid to model the 3/4. 1, 2, 3, 1, 2, 3, 4. And because we're modeling 3/4, we need to find 4 of something. 1, 2, 3, 4. Found it. I'm going to partition the shape into fourths, and then I am going to shade in 3 of the fourths. There's 1/4, 2/4, 3/4. 1, 2, 3, 3, 6, 9, 3, 6, 9, 12. So 3/4 is equivalent to 9/12. We don't ever add denominators, so I simply rewrite the denominator. We don't ever add denominators. All right, so 8 plus 9 is 17, but I'm going to go ahead and check with my area model. 1, 12, 2 12s, 3 12s, 4 12s, 5 12s, 6 12s, 7 12s, 8 12s, as I suspected, 9 12s, 10 12s, 11 12s, 12 12s, 13 12s, 14 12s, 15 12s, 16 12s, 17 12s. Now what I need to do is simplify, and I can tell that 17 12ths is not simplified because it's improper fraction. Improper means not proper, so we need to make it right. So what I'm going to do is I'm going to take away a whole. I remember counting. Here's 4 12ths, 8 12ths, 9 12ths, 10 12ths, 11 12ths, 12 12ths. So I'm going to take away that 12 12ths. And that should leave me with 1 12, 2 12s, 3 12s, 4 12s, 5 12s. So this is 1 and 5 12s. So 2/3 plus 3/4 equals 1 and 5 12s. 1.5 would be 1 and 6 12s, and 1 and 5 12s is very close. So I trust my sum. All right. This time I have 3 add-ins. I'm still going to use a rectangular model, but I can't necessarily do a 3 by 6 or a 6 by 4 because those are different denominators. I need the same denominator. But let me estimate first so I know how large or small my sum is going to be. 2/3 is about 1/2. 5/6 is about a whole. And 1/4 would round to 1/2. So 2 halves plus 1 would be 2 halves is 1, and then 1 plus 1 is 2. So my sum should be about 2. All right, what I'm going to do is I'm going to count by 3s, 4s, and 6s until I say a number all 3 have in common. 3, 6, 9, 12, 4, 8, 12, 6, 12. So my denominators are going to be 12. So I'm going to think about what each of the denominators have to do with 12. 3 times 4 is 12, so I'm going to make a 3 by 4. 1, 2, 3, 1, 2, 3, 4. And I'm modeling 2/3, so I need to find 3 of something. and I need to shade in 2/3. 1/3, 2/3. 1, 2, 3, 4, 4, 8, 4, 8, 12. So 2/3 is equivalent to 8/12. Now what do 6 and 12 have to do with each other? 6 times 2, 1, 2. So I'm going to make a 6 by 2. 1, 2, 1, 2, 3, 4, 5, 6. And then this time I'm going to partition this shape into 6 equal parts. If I go up and down, that's just 1, 2. 1, 2, 3, 4, 5, 6. And I need to shade in 5, 6. One, 2, 2, 4, 6, 8, 10. 2, 4, 6, 8, 10, 12. So 5, 6 is equivalent to 10 twelfths, excuse me. Now looking at 8 twelfths and 10 twelfths, they have the same denominator, so technically they have the same area. It just looks different, so the holes are the same, 12 whole pieces. All right, now 1/4. What do 4 and 12 have to do with each other? Well, 4 times 1, 2, 3 gives me 12. So I'm going to make a 4 by 3 to model the 1/4. 1, 2, 3. 1, 2, 3, 4. And because I'm modeling 1/4, I need to partition this shape into 4 equal pieces. 1/4, 2/4, 3/4, 4/4. And I need to shade in 1/4. 1, 2, 3. 3, 6, 9, 12. So 1/4 is equivalent to 3/12. Now I can add my add-ins because they all have the same denominator, 12. So that would be 8 twelfths plus 10 twelfths plus 3 twelfths. And we don't ever add denominators. So I rewrite the 12. I know that 10 and 8 give me 18, plus 3 is 21, but I have a model here so I can simply count. So here's 8 twelfths, 10 twelfths, 12 twelfths, 14 twelfths, 16 twelfths, 18 twelfths, 19 twelfths, 20 twelfths, 21 twelfths. So I am correct. However, this is an improper fraction, which means it's not in its simplest form. I need to take away a whole. Well, here's 8 twelfths, 10 twelfths, 12 twelfths. So here's the whole that I'm going to take away. So 21 twelfths minus 12 twelfths gives me 9 twelfths. Let's verify that. 2, 4, 6, 7, 8, 9 twelfths. So that leaves me with 1 and 9 twelfths. Now, I still need to make sure this is in simplest form, so I'm going to find my factors, 9 and 12. 1 times 9, 3 times 3. Factors of 12, 1 and 12, 2 times 6, 3 times 4, and the greatest common factor of 9 and 12 is 3, which means I can divide by 3/3 to get the simplest form. So 9 divided by 3 is 3, and 12 divided by 3 is 4. And remember that I had one whole, I can't leave that off, that'll change the value. So 2/3 plus 5, 6 plus 1/4 is equivalent to 1 3/4. And 1 3/4 does round to 2.